Alright, we are in Chapter 2, Section 2 for this lecture, and we're going to cover reference angles, special angles, and angle measurements. Alright, so reference angles, very, very important. We're going to need to know how to do those when we do unit circle stuff. Special angles, right, those are going to apply to like our 30, 60, 90 triangles, and then we can do all kinds of different angle measurements using our special angles, which are the 30, 60, 90 and the 45, 45, 90 that we covered last lecture. Alright, but first of all, let's understand a reference angle and how to determine the reference angle. The reference angle always comes from the x-axis. If you can remember that, you're good. So in the first quadrant, the reference angle is the angle itself. Alright, so there's not a particular reference angle that's special in the first quadrant, it's its own angle. Angles 2, 3, and 4 are the ones that have a reference angle. We use a reference angle because it consolidates it down to where we can use right triangle trig to solve the actual angles or ratios or what we need for a much larger angle. Okay, so if we take a look here on the far left hand side in quadrant 2, theta in blue, alright, going from the x-axis and terminating in quadrant 2, that's theta. But the reference angle is what's in pink right there. That's theta prime, alright? So just theta with an apostrophe, we're going to call theta prime. But that's the actual reference angle that we're going to use, alright, to kind of, I'm going to say, solve that vector in essence, or the magnitude, as far as when we're doing that. Okay? If we look at quadrant 3, the reference angle goes from the x-axis down to the actual angle. Notice theta goes from x counterclockwise and all the way into the third quadrant. That's our theta. Alright, and then theta prime goes from the x-axis and drops down to the blue ray there. That is our theta. So theta prime is the reference angle. Those are going to be specific values. Alright, then we look in quadrant 4. Quadrant 4 is from the ray to the x-axis. So please, 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 please remember, when you do anything with a reference angle, it has to be between the magnitude and the x-axis. So notice where it's placed in quadrant 2, placed in quadrant 3, and where it's placed in quadrant 4, based on the size of the angle that we have. Okay, so to find the one in quadrant 2, you're going to take 180 minus whatever that angle is. So we're looking at quadrant 2 here. The theta in blue, let's pretend it's 120 degrees. Okay? So if we know that theta is 120 degrees, the x-axis is 180 degrees, theta prime has to be 180 minus the 120, so theta prime would be 60 degrees in that case. Alright, so anything in the second quadrant, we subtract from 180. Anything in the third quadrant, we add to 180. Okay, or we take that angle, and minus 180. We still find that difference. Okay, so case in point, let's say theta, I'm doing the middle one here. Let's say theta is 210 degrees. Alright, and we got to go back to the x-axis. So 210 minus 180 degrees is what? 30 degrees. So theta prime in that scenario is 30 degrees for our reference angle. Notice it's a nice 30 degrees, so we can actually apply our 30, 60, 90 triangle when we do that. Alright, so let's look at quadrant 4. Okay, let's say theta is 300 degrees. Alright, so that would mean theta prime has to be what? 330, because we know that there's 360 degrees in a circle, so you would have to do 360 minus 330. Okay, so this is going to start to make sense here, but make sure that you terminate only to the x-axis for the reference angle, not the y-axis. Alright, so let's find this reference angle here. We have theta of 218 degrees. So as you guys get used to doing these, I would always draw yourself the crosshairs, right? Draw yourself a Cartesian coordinate system with an x and a y axis. Alright, and then draw the actual angle so that you know what quadrant it lies in or lands in. Okay, and then know if I'm going to subtract it from 180, Alright, subtract from 360, or how I'm going to get the angle that I need. So, take a look at this. Alright, draw it. I would always draw it. So we can see how 218 degrees is drawn, right? We start at X, we rotate counterclockwise, we go past 180, and we end up at 218 degrees. Well, the reference angle is the angle between the x-axis and 218 degrees. So that's why we're going to take 218 minus 38, and now we have a reference angle, or I'm sorry, 218 minus 180 gives us 38, and 38 is our reference angle there. 38 would be the angle that we would do sine, cosine, and tangent of. Okay. So, let's do another one. What's scary about this one, right? Well, it's greater than 360. So we got to keep track of how many times we've gone around the circle, right? Once around is 360, twice around is 720, 3 times around is 1080, okay, and so on and so forth. So we have to find where the reference angle lands first. Which quadrant? So remember, we have to find a coterminal angle. Alright, so that was from chapter 1, a coterminal angle. So we have to find another angle, okay, that's less than 360 degrees that ends up in the same location as the 1387 degree angle. Alright, so first let's find that coterminal angle. Well, we know that we can make 3 terms, like I said, so 3 times 360, that's 1080. So I gotta make a 1387 minus 1080, right? That's 3 times 360 is 1080, 307. So that's, okay, my coterminal angle is 307 degrees. That's not the reference angle, so don't get confused there. That's the coterminal angle. That means that's where the 1387 degree angle lands. Where is 307? Which quadrant is that in? That's in the 4th quadrant. Okay, so draw these out. Once you draw out where 307 is in the 4th quadrant, alright, I know that if I'm in the 4th quadrant, I have to take 360 minus 307 to get that angle. Alright, so that'll be the reference angle. So we know that it's 53 degrees, and when we draw it out, I would draw first, then do the calculation. So we can see where 307 is. It's in the 4th quadrant. Alright, and then we have to take 360 minus 307 to get that 53 degrees. We must have the reference angle that goes between the x-axis, alright, and the hypotenuse of whatever triangle we're forming there, or where theta actually is the vector of where it is. So take a look at this. I would pause the video and write all of these down. So remember, when we first started this, in quadrant 1, that's in the upper right hand quadrant, okay, theta and the reference angle are the same angle, okay, because everybody's positive there, and there is no reference because it goes back to the x-axis. So when you draw the reference angles, these are your only 4 choices for how your reference angles will be drawn. Do not ever mark the reference angle back to the y-axis. It always has to go back to the x-axis. So in every single one of these, if you notice, right, the theta prime, the one that's in pink, is always in the top 2, all right, going to the x-axis, and same in the bottom 2, it's coming from the x-axis in that scenario. So it's whatever angle forms between the original angle and the x-axis in that side. Very, very, very important, all right? So that's why we need to notice, you know, in the 2nd quadrant, how that vector points out, because theta swings open counterclockwise, okay, landing in the 2nd quadrant. Then we got to go from that vector, that magnitude, down to the x-axis. Hopefully this is kind of clear. I don't really think that this is too complicated. It's a little bit, you know, different for what you've done, all right? But there's how we find the different reference angles. So if we are in quadrant 2, you're going to do 180 minus whatever theta is. If we're in quadrant 3, you're going to take theta minus 180. If you're in quadrant 4, you're going to do 360 minus theta, all right, whatever your given angle is. It's also imperative when we start paying attention to these, all right, the x value and the y value. So if we look at the 1st quadrant, the x and the y on that magnitude, are both positive. If we look in the second quadrant, right, y is positive and the x values are negative. If we look in the third quadrant, the x values are negative and the y values are negative. And if we look in the fourth quadrant, the x values are positive and the y values are negative. It kind of goes back to the all students take calculus aspect too. So that way when we start writing out our trig ratios based on our reference angle, all right, it will make sense if our x is positive or our y is negative, or x is negative, y is negative, or x is positive, y is negative, that sort of thing. So let's find the values of 6 trig functions for 210 degrees. What I want you to do is pause the video, draw an x and a y axis, draw 210 degrees, and find the reference angle on your own. You should know based on 210 degrees what quadrant are we landing in. We're landing in the third quadrant. So if we go back and take the rule, all right, we have to do what? Theta minus 180. So we're going to take 210 minus 180. We should get 30 degrees, right? So when we do this and draw it out, look what that reference angle makes. Okay? It makes, from our previous lecture, a 30, 60, 90 degree triangle. We now know all the values of that triangle and the ratio. It's very, very important that you understand that. Hopefully these are all going to break down to nice 30, 60, 90 or 45, 45, 90. So when we do this, it's much easier for us to write the trig ratios that we know. Now, what I want you to really pay attention to is this is in the third quadrant. The x value is what? Negative. The y value is negative. Remember when we talked about all students take calculus? Okay, that acronym as we go around in the quadrants. Well, the third quadrant is what? A T for tangent. That lets me know what? Tangent is the only trig function there that will be positive. Tangent and cotangent. Remember, all students take calculus. All of them are positive in the first quadrant. S for students. Sine, that's the second quadrant. Take, T for tangent, that's the third quadrant. And C for calculus, okay, that's the fourth quadrant, and cosine. So we are in the third quadrant. The only trig ratios that will be positive will be tangent, because it'll be a negative over a negative equaling a positive. Your sine and cosine values you must write as a negative, okay? Same with cosecant and secant when you do those. All right, so our point of reference, hence the reference angle, is 30 degrees. So we write everything 30 degrees. So that this triangle is easy, it's a 30, 60, 90, we'll write it in a base form. Remember, that's a 1 square root of 3, 2 triangle from a previous lecture. So let's just assume the magnitude r is 2. Alright, so a distance from the origin out to point P, let's say that's 2. That makes it easy for us. How do we know where to place the 1 and the square root of 3? Remember, the smallest values across from the smallest angle. Alright, so we have a choice between a 1 and a square root of 3. Well, we know a square root of 3 is bigger than 1, so the square root of 3 has to go opposite the 60 degrees. So x is going to be square root of 3. But because of the quadrant we're in, that x value will be a negative square root of 3. The y value is across from the 30, so the y is going to be 1. But since we are in the third quadrant, the y value has to be a negative 1 because it's going down. Alright, x and y are both negative quantities for this example. So we know if r is 2 and x is the negative square root of 3 and y is negative 1, you guys from all the previous couple lectures, we should all know how to write sine, cosine, tangent, cosecant, alright, secant for all of these. So I want you to pause it and I want you to write the trig functions and then hit play and see if you got them all right based on that reference angle of 30 degrees. So everything you're doing is based on the 30. So sine of 210, we're using the reference angle, so it's really sine of 30, right, is opposite, so it's going to be negative 1 over the hypotenuse, so negative 1 divided by 2. So we're going to write it as sine of 210, but we're using the reference angle of 30 degrees to get the ratios. So make sure that you understand that, okay? Sine of 210, we're using the reference angle to get the values here. So cosine, remember that's adjacent over hypotenuse. The adjacent, the x is negative square root of 3, the hypotenuse is 2. Okay, and remember for this problem we arbitrarily chose the radius as 2. There was no like, oh, because it's this. It could have been something else, it would change the values, but we made it a 2 because this is a 30, 60, 90 triangle. Alright, so tangent is opposite over adjacent. So remember it's going to be negative 1 divided by negative square root of 3. We have two steps to do here. We have a negative over a negative, so that makes it positive. The second, we have a 1 now over a square root of 3. Remember, we need to rationalize the denominator, so we have to multiply 1 over the square root of 3 by square root of 3 over square root of 3. So remember, we've done that in a couple previous lectures. I'll make sure I'm doing that on the board for you as well, so that you can take a look. Alright, so now cotangent just means we're writing the inverse of tangent. So it's really square root of 3 over 1, which is equal to the square root of 3. Alright, remember secant is tied to cosine. So we flip cosine, so now it's negative 2 divided by square root of 3, but we cannot have a radical in the denominator, so you have to rationalize the denominator. So multiplying 2 over negative square root of 3 by square root of 3 over square root of 3 gives us negative 2 square root of 3 over 3. And then lastly, alright, we have cosecant. We're flipping cosine, we're flipping sine. So since sine is negative 1/2, we flip that and we end up getting negative 2. So most of your homework assignment is going to be doing stuff similar to this. Alright, what do we start with? We have the angle 210, so we drew it. We drew an x-axis and a y-axis, and we drew where the angle was located. That was important, one, to find the reference angle, so we had to take 210 minus 180 to get the reference angle of 30. Then we had to, we arbitrarily chose r. You're going to know that based on where you draw it and on your homework assignment. Then, okay, based on r and based on the angle measurements of 30, 60, 90, we knew what x was. X was going to be negative square root of 3 because it's across from the 60. And we know that x or y was going to be negative 1 because it's across from the 30. Alright, we were able to use those to write all the ratios. Now what I want you to know, if the reference angle was 60 in this case, alright, and not as it's drawn, but let's say the 30 and the 60 were swapped, the x and the y values would swap as well. Okay, just so make sure that you know it's based on where that reference angle is. Okay, so just some quick steps. We kind of went through these, kind of step by step, so you can pause and write these down and read through these. But we've done them as we did the examples. So go ahead and pause and write all these down, and then we'll move forward. Alright, so let's do this one. We want to find the exact value of cosine of negative 240 degrees. So what I want you to do first, draw negative 240. Remember, what's the difference between a positive and negative angle? The direction of rotation. Remember, if it's positive, we start at the x-axis and go counterclockwise. If it's negative, like this scenario, we start at the x-axis and we rotate counterclockwise 240 degrees. So you should know what quadrant we end up in. Okay, should be in quadrant 2. So draw that out and then take a look. You should have drawn this. Alright, negative 240, we start at the x-axis, we rotate clockwise because it's a negative angle. Okay, we end up in the second quadrant, so we had to find that reference angle. That's the difference between the 180 and the 240. Remember, 180 is the x-axis and the reference angle has to go down to the x-axis. So the reference angle in this scenario is 60 degrees. So draw yourself a 30, 60, 90 degree triangle. Alright, once we have the values. That should make sense, right? If it's 30, 60, 90, you should know what the side lengths are. What are they going to be? 1 square root of 3 and then 2 for the magnitude. But what we have to do when we do this is we're in the second quadrant. What values positive and what value is negative there? Well, all students, so sine's going to be positive, so is cosecant, all right? Meaning what? The x value or the x component of this will be negative. The y component, okay, of that vector will be positive. So when we write this out, and I didn't ask you to write all the trig functions, right? I only asked you to write cosine. So cosine of 120, and we use the reference angle of 60 degrees, and we learned from before, okay, that cosine of 60 is 1/2, but since we are in the second quadrant, cosine is negative in the second quadrant, so it becomes negative 1/2. How did we know cosine of 60 was 1/2? Well, last lecture we talked about a 30, 60, 90 triangle. Last example, we did a 30, 60, 90 triangle. So we have to know that a 30, 60, 90 triangle, that what? The 1/2 is the larger sine. We're dealing with the cosine of that angle. Alright, so we won't have, the square root of 3 will be opposite the 60. Okay, the 1's going to be adjacent to cosine. The 2 has to be the hypotenuse in the 30, 60, 90. Or review more in class. Or email me if you have questions, if you're doing this from home and you need to understand what's going on. I'd be more than happy to do that. We can Zoom or we can team meet or those sort of things and work through it. Why don't you guys pause and try this one on your own, but I'm going to keep rolling and do it. So first step in your mind, we have to find what? This is bigger than 360, so we need to find the coterminal angle. Alright, so we have to find out, if we go 360 plus 360, we're at 720. So we know that we don't have to use 2 rounds. Alright, but we're going to be less than 2 rounds on this. So we have to find the coterminal angle first, draw this out, then once we draw that out, then calculate the reference angle, and then use the reference angle to find the exact values here. Alright, so when you draw this out, notice we've drawn it around twice. Start at the x-axis, rotate all the way around 360 degrees, and keep coming, alright, till you get to 675. Well, if we went around twice, it would be 720 degrees. So you're going to take 720 divided by 6, or minus 670. 720 minus 675, not divided. Alright, you're going to get, what, 45 degrees. Or, you could have taken, alright, 675 minus 360, that's what's remaining, okay, and get 315. And then know 360 minus 315 is 45 as well. So you could have done it either way. I would have gone, hey, I know that 2 rounds is 720, 720 minus 675 is 45. Now I have my reference angle. Now I know the value for x, y, and the magnitude or the hypotenuse piece once I draw that triangle, right? Now, what quadrant are we in? We are in the 4th quadrant, so you have to know which trig function is positive in the 4th quadrant. Cosine is. So that you know we're finding tangent of 675, your answer has to be negative. So I need you to make sure that you really pay attention to when your answer should be negative and positive. Why is it negative? Well, we're in the 4th quadrant. The x value is positive, the y value is negative. We're finding tangent. Tangent is what? Opposite over adjacent, or vertical over horizontal. If the vertical is negative, right, the answer has to be negative. So when we work through this, alright, we do our triangles that we learned in a previous lecture of a 1, 1, square root of 2 triangle, because it's a 45, 45, 90 triangle. So we can say that tangent of 45, okay, using our 1, 1, square root of 2 triangle, remember tangent's opposite over adjacent, so it's 1 over 1, which is 1, but since we are in the 4th quadrant, tangent is negative, so tangent ends up being negative 1. Alright, so this example, and we can go over more on the board, but what you need to do when we get this, and I ask you to evaluate cosine of 120 plus 2 times sine squared of 60 minus tangent squared of 30. Your first step in this problem is you need to do exactly what we've been doing for cosine of 120, for sine of 60, and for tangent of 30. You need to draw each one of those angles, find its reference angle, okay, and then what? Use those ratios. Now, the only one, the sine of 60 and the tangent of 30, those are both first quadrant angles. So that one should be pretty easy to calculate because we have a 60 and a 30, so we're using a 30, 60, 90 triangle to get those ratios. Then cosine of 120, right? 120 ends up in the second quadrant, so we do 180 minus 120, and so we're doing cosine of 60. Hopefully we've done these enough, alright, but we're going to skip ahead. In class, I'll maybe get into this example a little bit more in detail, or if you need me, if you cannot figure out what I'm about to show you where these come from. We just did 2 or 3 examples of where these values come from, not specific to this problem, but how to find it, alright, and I just kind of walked you through it. So we know that cosine of 120 degrees is negative 1/2. We know sine of 60 degrees is square root of 3 over 2, and we know that tangent of 30 is square root of 3 over 3. We did all this anyways when we did the lecture for the 1 square root of 2 triangle and the 1 square root of 3 2 triangle for the 30, 60, 90, and 45, 45 one before. So these shouldn't be anything new to you. You made a whole chart that filled all these out as well with the reference angles. Alright, so cosine of 120, so we're going to have negative 1/2 plus 2 times, remember that's sine squared. Sine squared, so we got to be careful there, and tangent squared. It means we're going to actually square the square root of 3 over 2 and the square root of 3 over 3 because they both have a squared associated with them. So we're going to substitute in the values, the known values or ratios that we just calculated. So wherever there's a cosine of 120, I'm putting in the negative 1/2. Wherever there's a sine of 60, I'm putting in the square root of 3 over 2. And where there's a tangent of 30, I'm replacing that with square root of 3 over 3. Notice I have to keep the exponent, the squared, that's on the sine and the tangent. And notice the coefficient of 2 in front of where the sine term was. Then it's just a matter of simplifying these down. Okay, so we're going to have negative 1/2 plus 2 times the square root of 3 divided by 2 squared ends up being the square root of 9, or the square root cancels, alright? So it's going to give you 3 divided by 4, alright, and then 3 divided by 9 on the end there, okay? So all we've done is squared those. I squared square root of 3 over 2, which got us 3/4. I squared square root of 3 over 3, which got 3/9, okay? Now, try to do these in your head, right? We know, it's a little harder. We got to find a common denominator, solve some algebra. I know you're used to putting this in your calculator and getting an equivalent decimal, all right? But it's a little bit hard. I'll go step by step in class of how to solve, the fractions for you if you need help and don't understand how we combine the fractions here. Remember, if we have a mixed number, which is the 2 and 3/4, you can take 2 times 4, which is 8, all right, plus 3 and get 11/4 when you do that. All right, this one's a little tougher because there's not a nice common denominator. You're going to have to multiply all those out. I'm pretty sure the common denominator is 36 here, and then you got to reduce that down. So, but let me know if you struggle with that and we'll get through. So the final answer is 2/3. All right, let's do one more here. We want to evaluate the cosine of 780, okay, and find the exact value of it. But first, right, we have to find the coterminal angle. 780 is more than what? 2 rotations, because 360 is 1 rotation, 720 is another rotation. So I've gone 2 rotations, so I need to be in 780. So I have to do 780 minus 720, which is 60. Where does that put me? That puts me in the first quadrant. Okay, that makes it nice and easy when I do this. Alright, so we're looking for a first quadrant angle. Cosine of 60. How much easier is that? Because now we know what the ratio is. It's a 30, 60, 90 triangle. Okay? Just being able to draw the triangle out right. So cosine of 60, alright, if you draw that triangle, okay, what's across from the 60? It should be the square root of 3. What's adjacent to that 60 should be a 1, right? And the hypotenuse of that triangle should be a 2. So we want to find cosine of 60, which is adjacent over hypotenuse. So we should get 1/2, and it should be positive because we're in the first quadrant and all students take calculus. That one's fairly straightforward, I think. Let's take a look at this one. We want to find cotangent of -405. So we have to find its coterminal angle. Now, remember it's a negative angle, so you got to be careful. If you draw it the wrong direction, you end up in the wrong quadrant. Remember the angle's negative, so we're going to start at the x-axis and go clockwise since it's a negative angle. So we're going to go clockwise 405 degrees. That means we're going to do a complete circle, 360, and then the difference between 360 and 405 is 45 degrees. So we are going to end up in the fourth quadrant. Okay? So when we end up in the fourth quadrant, our reference angle is 45 degrees. That makes it nice and easy, right? We already went over the 45, 90 triangle. It's a 1, 1, square root of 2 triangle. Both legs are 1. The hypotenuse is square root of 2. Alright? So when we do this, and we are in the fourth quadrant, right? Your x value is positive, your y value is negative, okay? And your cotangent, right, is adjacent over opposite. So adjacent is 1, your opposite is -1, so 1 divided by -1 is 1. Okay, if you're struggling with this part, draw the triangles out more like we did at the beginning of the chapter, or the lecture here. If you draw those triangles out, alright, you'll be able to kind of see the ratios a little bit. And we'll go over it on the board as well. I would have drawn this one out for you, but my stylist, you saw last lecture, I'm trying to get a new one in so that I can draw this out with you as we do. And see, it's just kind of all over the place right now, and the batteries aren't charged on my other one. Well, they're not charged, they're not working. But anyhow, we will we'll make it through all this, guys. But if you have questions, email me, or we can Zoom meet or team meet, or I'll try and work it out on the little write up tab thing. So just really review the last lecture where we talked about 30, 60, 90 triangles and 45, 45, 90 triangles. Okay. All right. So we want to find all values of theta if theta is in the interval 0 to 360. Notice we're including 0, not including 360. And cosine of theta is -2, or negative square root of 2 over 2. So we have to find, all right, what's going on here. All right, negative, or square root of 2 over 2, that looks like what? We've undone some rationalizing the denominator. At least to me. All right, so you got to think of when you start seeing something like a square root of 2, you need to start thinking about a 45, 45, 90 triangle. We see square roots of 3, we see 2, and we see the 1 and the single 1. Then we're thinking 30, 60, 90. But if we're getting a square root of 2 somewhere, we need to be thinking the 45, 45, 90 triangle. Okay? So, cosine's negative, so we have only 2 possible answer choices. When is cosine negative? You have to remember that all students take calculus. So, cosine is positive in the first and fourth quadrant, and it is negative in the second and third quadrant. So the answer we're looking for has to be in either the second or the third quadrant, or it could be in both, essentially. But let's take a look here. Where is this one lie? Okay, the quadrant 2 angle, all right, is 180 minus 45. Okay, we know based on the square root of 2 over 2, I told you that it's going to be a 45 degree reference angle. So we're going to do 180 minus 45, so that we know that that theta is 135 degrees there. Our reference angle is 45, and we are in quadrant 2 for this. Okay, if we do the quadrant 3 angle, right, we're still using the reference angle of 45. We're going to take 180 plus 45 and get 225. So those are our 2 solutions. So in this case, we're working backwards. I'm giving you a ratio. You're using that ratio to find the angle. All the other examples we've done, I've given you an angle and asked you to find the ratio. So we're going backwards in this case. We're using the ratio to find the angle. Okay, so we are working backwards. So I know this one's confusing, but I want you to think back. Cosine, if we're using a 45-degree angle, okay, so draw yourself a triangle that's a 1 square root of 2 triangle and put your two 45s there. If I asked you to find cosine of 45, you would say, oh, it's 1 divided by the square root of 2. Alright, so bear with me. 1 divided by the square root of 2. So remember when we rationalized that denominator, we had to multiply by square root of 2 over square root of 2. Well, that's where this negative square root of 2 over 2 comes from. When we rationalize cosine of 45, right, is 1/2, or 1 over the square root of 2, alright, and then we rationalize that by multiplying by square root of 2 over square root of 2, that's where we get square root of 2 over 2, okay, when we rationalize the denominator. So that's where this is coming from, alright. I'll make that more clear if you need me to in another email, or if you need a video chat, or like I said, in class, I'll get more indefinite on this one on the board when we go through it. That is it for Chapter 2, Lecture 2.